Raise your hand if you still have a broker that uses classic mirrored queues. Okay, I see most of you. I promise this will be the only time where I get excited about people not yet using Quorum queues. My name's Stefan Moser, my pronouns are he, him, and I'm a principal engineer at AWS working on Amazon MQ. One of the things I like best about my job is that I get to talk to a lot of users about how they use RabbitMQ. And when I ask them why they haven't migrated to Quorum queues yet, I get answers like, it's too hard, I'm going to have to change too much code, it's going to take too long. But when I walk them through the steps that's actually needed to get to Quorum queues, they see how much easier it is than they actually had thought. So today we're going to go through some of the reasons to migrate to Quorum queues. So we'll cover why Quorum queues are actually better than classic mirrored queues and why you would want to do this migration at all. We'll talk about how you can prepare to migrate and how a little upfront work will help you ensure that your migration goes smoothly. And then we'll go through 3 different methods to migrate. There's not one method that's going to work for everybody, so we'll talk about when to use each different method and how you can identify the right one to use for your application. So let's start with why Quorum queues are better than classic mirrored queues. Well, simply, they have higher throughput. So here's the results of a benchmark test that I ran. I created 2 identical brokers with identical configuration and put identical load on them. The only difference was that the load on one broker was Quorum queues and the load on the other broker was classic mirrored queues. And as you can see from the graph here, the green line is the Quorum queues, and we got about 5 times higher throughput, both on the publish rate and the consume rate. In the same benchmark test, if we look at latency, on the publisher latency side, we can see about 6 times lower latency for Quorum queues. And on the consumer latency side, we see the Quorum queues just have a very consistent consumer latency, and the classic mirrored queues have these really crazy spikes where we see sudden increases in the consumer latency. Quorum queues are more reliable, as V talked about in his presentation. There are a lot of things that we can do to make sure that they operate as we expect. They're more predictable, as we just saw on the last slide. The Quorum queues had very predictable latency, as opposed to the classic mirror queues that had high spikes. And they require less maintenance. The underlying Raft log is a very simple mechanism that Quorum queues use that allows us to operate Quorum queues with a lot less maintenance. We don't have to worry about things like we do with queue syncing in classic mirrored queues, where if a node is disconnected for a period of time and it reconnects, it has to resync the whole queue. Quorum queues will just catch up to whatever they've missed if a node is disconnected for a while. But the simplest way to put this, as I like, is in a blog post written a few years ago by one of the people at VMware at the time, is that Quorum queues are better in all regards. And so that's really all you need to know. If there's ever a question, should I use classic mirror queues or should I use Quorum queues? The answer is always Quorum queues. But if you're still not convinced, it's the end of the road for Quorum queues. A few weeks ago, 4.0 was launched, and the ability to mirror classic queues was removed. And so it's really now is the time. But having said all that, and the number of you that raised your hands earlier, I went and looked at our fleet and tried to see the usage of Quorum queues. And only about 4.4% of queues in our fleet use Quorum queues. Now, I have to admit, when I was preparing these slides, I started the process late to ask permission to be able to use this, so I wasn't sure I was going to use this slide. So I also asked ChatGPT to visualize this for me and tell me the difference between the usage of classic queues and Quorum queues, and this is what it came up with. Yeah, AI image generation is pretty good, but apparently spelling is something that it can't do at the same time. All right, so let's talk about how to prepare to migrate to Quorum queues. So Quorum queues are not a drop-in replacement for classic mirror queues, which means there are some incompatible features. So there's a list of features here. There are alternatives for all of them. Some of them are a little bit edge casey, and some of them are things that if you want a replicated queue type like Quorum queues, you're probably going to want to make sure that they're durable. So we won't go through all of these today, but I'll share a link to that blog post that I was referencing earlier at the end, which has good alternatives that you can go through and figure out what you would want to do if you actually are using any of these features. The other thing that gets a lot of people when migrating to quorum queues is the use of policies. So we have this policy defined. It matches all of our queues. We have a message TTL of 60 seconds, and because we're still on classic queues, we have the HA properties to mirror it. But what would happen if we created a quorum queue? We still want to keep the message TTL. So let's see what happens. So we're going to list our policies. We see here we go. We've got that policy in place, and we declare a new queue called Summit Quorum of type quorum queue. So let's have a look. What policy does this match? Well, it doesn't match any policy. But we did have a classic queue that it matched. But if we add a new policy that is exactly the same, but just has those HA properties removed, and now we look, now it matches our policy. So this is one of the big gotchas with policies, is that we have to make sure not only does the policy match the queue, but it also has to not use any of the HA properties, any of the properties that are incompatible with quorum queues. So a good idea is to go through your policies first, maybe make copies of them all, remove the HA properties and the other things that aren't going to be compatible. You can also set them to apply to only quorum queues. The demo that we just saw, that was applying to all queues, so it's not necessary, but it might help you separate the two if you're going to be making copies of your queues. Okay, so let's get in how to migrate. So what better way to show you how to migrate than to migrate an application for you? This is going to be a very simple demo application. So here, it's a small Python application using the Pika library. So here's my producer code. When it starts up, it declares a queue. It declares it as a classic queue. And then in a loop, it publishes a message with the current timestamp, also prints it out to the console, and then sleeps for a second, and then repeats. Here's our consumer. When it starts up, it subscribes to our queue and provides a message callback, and that message callback, when it receives a message, prints the message out to the console and sends an acknowledgement back. So let's have a look at this live here. We've got the producer in the bottom left and the consumer in the bottom right. We see some messages being published and consumed. And we'll just remind everybody what the line of code looks like that declares the queue. It declares it as a classic queue. And yes, we have a classic queue currently. So let's see what happens. Let's change that line of code. Instead of declaring it as a classic queue, let's declare it as a quorum queue. Let's see that code change worked. So let's stop our producer, reload it, and start it up. And oh shucks, that didn't work. This would have been a very, very short presentation if that had worked. But why didn't it work? So we have this precondition failed exception. Let's have a closer look at that. So it says precondition failed. There's an inequivalent argument XQ type for the queue in the vhost. It received quorum, but the current is classic. And so what this is saying in RabbitMQ, you can redeclare queues. It's an idempotent operation, but you have to make sure that you're using the same properties. So let's go through the three ways that you can migrate. These are going to go in, I guess, like ascending order of complexity. The simplest one, the easiest one to do is simply just to delete and recreate your queues. Yes, it's actually a valid method of migration. Then we can go through migrate in place, and the final one that we'll look at is migrate by vhost. So the first one, delete and recreate. So the steps that you would actually go through here is, because we're going to be deleting and recreating the queue, we need to block the producers and the consumers. Then we would delete the classic queue, recreate it as a quorum queue, recreate the bindings, and then unblock the producers and the consumers. As we go through the demos here, I'm going to skip the recreate bindings part because, as you saw, the application, it uses the default exchange with the implicit queue binding, so it's not necessary. But as you're doing this on your real applications, that is a step that we'll have to take along the way. So some of the good things about this method, well, it's by far the simplest. It's quite simple to think about. We can do it with no code changes. It does require blocking the producers and the consumers, so depending on how long this process is going to take, if you can schedule some downtime for your application, that would be ideal. But since we're deleting the queue, it does not preserve the messages. So use this method if blocking producers and consumers is not a big deal. And hopefully you can consume all the messages in the queue so that there's no messages to lose. Or maybe they're not all that valuable for you and you can just delete them anyway. So let's have a look at how this would work. We've got our application running. Yes, it's a classic queue, so we're going to stop the consumer and the producer. That's our act of blocking the queues. And then here we go. We'll just delete the queue. And then now we're going to redeclare it using the RabbitMQ admin tool, recreate it, but this time we're going to create it as a quorum queue. So now that we've done that, we can reload our producer or start our producer up and start our consumer up. It's all running again. Let's look. Let's make sure that it's actually created as a quorum queue. Yes, it is. But if you remember, our line of code that was redeclaring the queue is a classic queue. So why does this work? Well, the reason that it works and we didn't get that proper invalid equivalence exception is because of this configuration setting that's being added. So let's have a closer look at this. So the configuration setting that you would put in your RabbitMQ conf file is a bit of a mouthful. Quorum queue, property equivalence, relaxed check on redeclaration. This was added for one reason and one reason alone. It was added to make the migration to quorum queues easier. So the only scenario that this setting will be used is if there's an existing quorum queue that is being redeclared as a classic queue. If that's the case, RabbitMQ says, you know what, we want you to make this change, so let's just let this one slide. As long as all the other properties match, then this will succeed too. So this is a really important configuration setting to have in your RabbitMQ cluster when you start migrating to quorum queues. It matters in this example, and it also matters in the other examples that we're going to go through shortly here too. Okay, so let's look at the second method of migration. So this is migrate in place. The same steps are fairly similar. We just have to block the consumers. But this time we're going to create a temporary queue. We're going to move all the messages to that temporary queue. Then we're going to delete the classic queue, create a quorum queue with the same name, recreate the bindings, move all the messages from the temporary queue back to the queue that we had. And by the time we unblock the consumers and the producers, it doesn't know that we've done this little switcheroo on it, and it'll just keep going on as normal. So some of the considerations, like, yay, we get to preserve our messages. So if assuming that our messages are actually valuable, we get to keep them. Again, we can accomplish this one with no code change, but it still does require that period of time where we're blocking the producers and the consumers. So again, you'd want to use this one if it's okay to block producers and consumers for a bit, and you have enough messages that you want to preserve them. It's going to be a little bit more complex than the last one. So let's look at it in action. We'll stop our consumer here. I let a few messages build up there. So as we look at our queues, we can see we've got 4 messages in our queue. So we're going to declare the shovel now, which is going to be from our source queue, Summit 2024, and we're to a destination temporary queue. The shovel is going to create the temporary queue for us. And we're also going to tell the shovel to delete itself after it has moved all the messages, because it's just a one-time operation. So now that this is running, if we have a look at the queues again, we'll see that it's created the temporary queue for us, and it's moved all the messages over to it. So now we're free to delete the old queue, and now declare the new quorum queue with the same name. Once we've done that, we can just use the same shovel declaration that we used, but we'll reverse the destination in the source queue. And that'll move all the messages back onto the queue that's now named Summit 2024, that's a quorum. And then we can delete the temporary queue. And then we'll start up our consumer. We can see it catching up there. It consumed those 4 messages, and then when we start the producer, it's also reading those messages. So the final method that we'll look at, this one's called migrate by vhost. So this one's a little bit different, is that we do need to be able to point the application in a little bit different way, because we're not going to have the new queues in the exact same place. They're going to be on a new vhost. So we create that new vhost and then have a federation upstream between the 2 vhosts, create the quorum queues in the new vhost, recreate all the bindings. Then at this point, we can point the consumers first over, point the producers second over, and shovel any remaining messages. So this one doesn't require any downtime. If you can point your consumers and your producers and redirect them over to the new vhost, if you can do that without bringing them down, then you can accomplish this without downtime. Obviously, it preserves the messages and doesn't require any code change. That's all assuming that you can point your producers and consumers to a new vhost without changing code. For simplicity's sake, in the demo, I did it through code, as we'll see in a bit. But sometimes this act of redirecting your producers and consumers might be a little bit more complex. So that's one of the downsides. And we'll also see that it doesn't necessarily preserve message order. So you have to be able to consume messages out of order. So you would use this method if you really can't tolerate blocking the producers and the consumers, and you want to preserve all of the messages. The biggest one is you're willing to deal with the complexity, and part of that complexity is that you can tolerate the out-of-order messages. So let's have a look at this one in action. So we're going to declare the new vhost. We'll give it a default queue type of quorum queues as well. So have a look to make sure. So we created the QQ vhost there. We've got the other one that is undefined, but that just defaults to classic. Here we are creating the federation upstream. It's a little bit long, but really all it's doing is just creating that upstream between the two. So now that we've got the new vhost, we'll create the new quorum queue on that vhost, and then we need a policy to apply the federation upstream to the new queue. And so this is the part about redirecting the consumer and the producer. So I just do it through a little bit of code here. And then I'm going to stop the consumer here and just pause a little bit just to let it build up a few messages, because that's part of what we want to show a little later. So it's going here. Now watch really closely as the producer starts up. What happens to the consumer? You see it's flip-flopping there where the messages are coming out of order. What's happening there is the consumer is pulling a message off through the federation because the queue's empty, so it's pulling it through the federation. But then the producer produces another message, so the next time it goes, there's a new one there, and it doesn't have to use the federation. So until it's consumed all the messages through the federation, we do get those out-of-order messages. And the rest of the things that just happened there was just a little bit of cleanup, and we see at the end we're just left with one queue that is a quorum queue. Okay, so really quick, we went through all of this. We talked about the reasons why quorum queues are better in every way. We talked about the two things you need to do to prepare to migrate, going through all those incompatible features and making sure that your application isn't using any of them, or that you've got an alternative. And we talked about how to prepare the policies. We went through the three methods of migration: delete and recreate, migrate in place, and migrate by vhost. And through all the demos, they were fairly simple demos, right? It was a very simple application. But it really just shows the purpose and the principles. And then you can use these principles to migrate to quorum queues no matter how complex your application is. If you needed to do this in batches, you can script all this. All of the demos used RabbitMQ admin, which means you don't even need back-end tools, right? You could do this all through tools that are directly available through the front end of RabbitMQ. If you wanted to do something like export your definitions from RabbitMQ and make a bunch of changes so that you didn't have to recreate queues one by one or policies one by one, there's a bunch of other efficiencies that you could do to make this easier. And even the last migrate by vhost, if you wanted to do some sort of blue-green deployment, all of those same principles would still apply for what you would need to do. So thank you. That brings me to the end. The QR code there is a link to that blog post on rabbitmq.com that goes into a lot of the more details for how you can migrate. Gets into a lot more details of the steps and particularly the incompatible features. Thank you.
Thank you very much. Okay, questions for Stefan?
Those kind of migration paths, are they all still relevant when you are upgrading Rabbit as well? Or what would be the recommended approach for doing both, upgrading and changing to Quorum queues at the same time?
Well, assuming that you're upgrading within the same major version, so all of these demos are on 3.13, right? Because we need a version that has both classic queues and Quorum queues. So if you're upgrading within the same major version, then you can just upgrade. RabbitMQ supports upgrading in place as long as you're going one minor version to the next. So you don't need to worry about migrating your queues if you're doing that. But then if you're going to go from 3.13 to 4.0, you have to have already done the migration to Quorum queues, because as soon as you would upgrade to 4.0, your queues would no longer be mirrored.
Cool. Will the shoveling and the federation moves still happen between versions? Or is that just something you'd have to...
They're just upgraded in place. Like your queues are just, when you upgrade a version, you don't need to, everything's preserved. Your queues are preserved, your messages are preserved. If you're running in a cluster, and you're upgrading nodes one by one, then everything will be preserved. And even if you're running a single node, as long as you're just going a single minor version, when you start up the new version, everything will just be upgraded for you. If you want to come up after, I can share some. I think there was a talk last year around upgrading too, and so there's a lot of good information there about upgrading versions. Definitely something you should be doing. Sticking on the latest version helps a lot in RabbitMQ.
Great, thanks.
I have two things. Thanks for the talk. If you are upgrading by vhost, you can make use of the default queue policy, so you can set it to Quorum. So
yes.
that could be useful. You mentioned moving consumers and producers separately. Do you have any way of knowing which connections have consumers on, and vice versa?
Generally, that's going to be knowledge of your application. But you can do a little bit of forensics. You can look in, you could go through the management console and you can look at connections and you'll see whether or not it's producing or consuming. You're going to have to do a little bit of diagnostics to figure out where that connection is coming from. I think that one of the talks earlier was talking about how it makes things simpler if your connections are either just producers or just consumers, at least at this point. If you're using AMQP 1.0, then it matters less, but generally that's something that you're going to have to just know how your application works and how it's consuming and producing. Just quickly to refer to your first point, yes, I had another demo recorded where the application was not declaring the queue type, and so initially the default queue type on the vhost, it was created as a classic queue. You can update the default queue type on a vhost. So one of the first things to do would be to update any existing vhost to use the default queue type of Quorum queues.
Cool, thanks, Stefan. With the relaxed on declare, was that an Amazon contribution? And part two, I guess, is what else does it relax on? Is it just the queue type, or durable false it ignores, or auto delete false it ignores, or just the queue type?
It's just that one very narrow little check, and it was intentionally added just to make the migration to Quorum queues easier. So it's not intended to relax any other checks. And yes, that was contributed by one of our engineers.
Hi. The benchmarking I've seen on latency for Quorum queues so far has been that it's higher latency with Quorum queues than classic queues, but I think that benchmarking was on 3.10. So is that no longer the case now?
This was done on 3.13. I think you'll see a difference whether, like this was specifically Quorum queues versus classic and mirrored queues. I think if you did like a single node test of Quorum queues versus classic queues, you would see higher latency on Quorum queues. You would have noticed that the consumer latency was generally faster on classic mirrored queues, except those erratic spikes. So it is a little bit different, but there's also has been a lot of improvements in quorum queues between 3.10 and 3.13. So I wouldn't be surprised if we did see latency improvements in there as well.
Okay, thank you so much.